In this video, we are going to be working to walk through our K-means algorithm with some fabricated small example data to help us get a better feel for what this algorithm is doing, and to also help us think through what might happen if we run the K-means algorithm with the quote-unquote wrong number of clusters. So right here, what I have visualized is our data that we've created. We started by creating 3 cluster centers in orange here, here, and here, and then creating 3 clusters of data around those centers. So we can kind of visualize cluster 1, cluster 2, cluster 3, or the Pythonic way of counting those, clusters 0, 1, and 2. And we're going to run our K-means algorithm and attempt to re-identify those 3 clusters. What we've done so far in this lab is we created some functions to help us. One function to help us find the distance from any given point to the centers, and another function that will take a query point and the list of centers and determine to which cluster that query point belongs. And we've also done the initial iteration of the first part of our K-means algorithm, which for us is to pick the proper number of cluster centers at random and then use that function we just wrote, the assign clusters function, to determine to which cluster each point belongs initially. Then we also worked to plot those 3 cluster centers here in this light tan color, those randomly selected points within our interval. And then we've used a different color for each initially assigned point to a cluster. So these 2 purple points right here belong to the cluster with this particular cluster center. These cyans belong to this one over here, and these darker greens belong to this cluster over here. That's the first part of our K-means algorithm. And the second part of the body of our K-means algorithm is after this initial assignment of observations to clusters, the second portion would be to recalculate the cluster centers based on the observations that have been assigned to that cluster. So that's where we'll resume in this video. We took a moment to explore with NumPy's mean function to figure out ways we could quickly recalibrate those cluster centers. And what we would like to do right now is fill in the following code in such a way that we recalibrate those cluster centers and then create another visual like we did above to visualize that progress. Previously, when we were plotting our clusters, one of the things we did was filter down our observations, or another word that I would like to use right now is partition our observations according to the cluster to which they belong, so that we could more easily graph them in a uniform color. I'd like to do this a little bit more methodically, so I'm going to go ahead and take that code where we filtered our observations, and I'm going to have that code be part of something we're building. So we're building a list, and we're going to use this list comprehension notation, and the objects that are going into the list are the partitions from which we took the code above, where we consider the tuples that belong to our observations only if the current attribution of that particular tuple is the ith cluster. And we need to do that for each I in the range of the number of clusters that we have. And we're trying to do this really Pythonically, which is why I'm using a list comprehension. I'm really going above and beyond by using a list comprehension within a list comprehension. And because this typing is running off the screen, I'm also going to be good in Pythonic here. And I am going to put in a line break right here to continue the line down one more. And then I can see everything without having to scroll side to side that's involved in that list comprehension. So again, what we're doing is we're really just creating the clusters. That's another word that I could use for this partitioned observation is clusters. So I will have, for this example, 3 things in this partitioned observation list because I have 3 clusters. And the elements in partitioned observations are lists of tuples. Don't think too hard about it. It's going to get lists upon lists upon lists. But really what I have done is partitioned my observations into the clusters. And that's why I've named it partitioned observations, or I could call it clusters. Once I have done that partitioning, what I want to do is step through each object in partitioned observations and use my NumPy mean function on that axis of 0 to calculate a new center. So let's be Pythonic and use a list comprehension. What we want to do is compute the NumPy mean of each partition in the partitioned observation along the axis of 0. And those will be our updated centers. So this line, line 4 right here, does the job of updating the current centers. We'd like to graph those current centers, but now let's begin that cycling iterative approach of the K-means algorithm. We recalibrated the centers. Let's also recalibrate the cluster assignment. Whereas you can imagine if this point, which is the supposed cluster center of these 2 points, once we redo that calculation and move this cluster center to being right in between those 2 observations, this cluster center should move somewhere over here to balance these points that belong to that cluster as well as these points that belong to that cluster. So we might have a cluster center right over here and another cluster center right over here. It's believable that some of these points might actually become attracted to this cluster center now, and they may turn purple, as once we have moved these cluster centers, the one that was previously the closest may no longer be the closest. So we reassign them, and then just becomes the graphing part. So the way that we're going to go about this graphing right now is just a little bit shorter and cleaner, a little bit less with the list comprehensions and more with the using of advanced data types. Now remember that we've seen all of this before. The logic to determine this cluster is precisely this bit of logic right here. So I'll just go ahead and copy and paste that. However, we are going to have to change this word. It's no longer current attribution that we're calling it. We're now calling it attributions. So let's change that. Having made this change, we've defined the cluster. What I actually want to do, just to make things read a little bit nicer, is I'd like to take this cluster, which is a list of lists, and convert it to a data frame where I just label the columns X and Y. The first value in that list is going to be the X coordinate. The second value will be the Y coordinate. And what's nice about this is I can then call the data frames scatter plot function and say I want the X's to come from my X column and the Y values to come from my Y column, and this is what I would like the color to be. It should be the ith color in my color list. And then it will just plot all of those points individually and plot them one at a time. When we're done, we'll tell Python to show us the plot. And let's go ahead and make our plot a little bit nicer by adding those cluster centers. I'm going to go ahead and plot those cluster centers in the way that we were plotting them before, simply so you can see why the data frame option is a little bit more elegant. So let's go ahead and do a scatter plot via a list comprehension, where we're saying I want to take the tuple in the 0th position for 2 in current centers. And those will be my X values. My Y values will be the same, except we'll be looking in the 1st position instead of the 0th position. And we also need to specify a color. And I believe I was using colors at something like -3. We'll ignore the legend for now. We'll say, make us a graph. And now we can see what's happened. The scale has changed a little bit, so let's compare and contrast to our previous picture. Our previous cluster centers were over here. We recalibrated. This one should shoot right into the middle of those 2, and those 2 should still belong to that cluster. And you can see that right here. And as we hypothesized, some of these observations that were previously closer to this cluster center, which is over there, are now closer to this one. So they've changed colors. They'll now belong to this cluster instead of this cluster. Not too much has changed with the assignment of observations that were in this green cluster, but the cluster center has changed. And this is the next step of our K-means algorithm. We'd now like to write a loop to kind of repeat this process until things settle down. You can tell from taking a look at this graph, and this is important, that this algorithm is not done yet. If these purple observations really were a cluster and that were the final output, this is not where the cluster center would be. It should come down a little bit and become a little more centrally located. Given that this cyan cluster lost some observations that were pulling the center to the right, this center should probably move a little bit to the left. And it's unclear what will happen with this cluster center. We'll just have to watch and find out. So what I would do to animate the rest of this, and writing a while loop would be really elegant, but we could just write a for loop if we want to just sort of copy and paste this code and repeat it something like 5 times, which is what we'll do to start out. Let's just grab that code, say something like for j in range of 5. Let's just repeat that process. Let's tab everything in and maybe add a print statement. And so we'll just go through this process of this was where we left everything. What if we made some updates and graphed as we went? Don't forget before we run this code that we did have a wording change. I used to call it current attribution, but now I'm calling it attributions. So let's go ahead and change that word right here. And then you can see that on the next iteration, we've gained even more points for this purple cluster. And in this cluster, moving a little bit to the left, we gained some of these formerly green data points for the cyan cluster. And again, by taking a look at this, you can tell that the algorithm has not stopped yet. This point is not really in the center of the purple points. This point is certainly not in the middle of the green points. So there's still more algorithm to go. And when we get to the next round, things are starting to look a little bit better. I would say it doesn't seem like we're totally done yet because I don't think this center is really where I would expect it to be given those observations. But by the time we get to this round, you can see that this picture and this picture and this picture are not changing. So you can see that our algorithm has converged and we were able to recover the 1, 2, 3 clusters that we initially started with. And now if I add a cell and I ask the computer to print the current centers and print the original centers, they're not far apart at all. Originally 0.75, 0.51, 0.75, 17, 0.5106, 0.42, 0.4, we have a 0.4179 and a 0.400. And last but not least, 0.84 and 0.25 matches up here with this 0.845, 0.246. So our algorithm converged after not that many iterations and was fairly successful in recovering our original cluster centers.